Here is a proof of Pythagorean identity. I draw a right triangle in which this is the opposite side, here is the adjacent, and this is hypotenuse side. What I did, I write the Pythagoras theorem, which is square of the sum of two small sides is equals to the square of the longer side. So I write it opposite side, adjacent side, their squares and equals to hypotenuse square. So I am dividing both sides with the hypotenuse square. I am dividing both sides with hypotenuse square. So this is cancelled and you get 1. What is opposite over hypotenuse? Sine theta. So sine theta. It's a square on the both, so it's a square whole square. Adjacent over hypotenuse, it's a cosine theta. So cosine theta whole square. So this is the first identity you got. Sine square theta plus cos square theta is 1. Now for the next, I am dividing both sides with the opposite square. Opposite square, opposite square, opposite square. This cancels and you left with 1. Adjacent over opposite is cotangent. So cotangent theta whole square. Hypotenuse over opposite, it's cosecant. Cosecant theta whole square. This is the second identity. Next, you can divide both sides with the adjacent square. I divide by adjacent square. Adjacent square, adjacent square. This cancels. Opposite over adjacent is tangent theta. So it's a tangent theta whole square plus 1 is equals to hypotenuse over adjacent. That's a secant. So secant theta whole square. These are the 3 Pythagorean identities. We derive it using Pythagoras theorem. And remember, if something is written sine theta whole square, this is the same as sine square theta. But this is not equals to sine theta square. In this case, theta is only the square term here. Square is only for theta. But here it represents the square of whole term. So this was Pythagoras identity.